4.2 Triangle Congruence Theorems in Unit 4, Relationships with Triangles. The first thing we need to understand is, what does the word congruent mean? Two geometric figures are congruent if they have exactly the same size and shape. Imagine cutting out one of the congruent figures. You could then position the cutout figure so that it fits perfectly onto the other figure. Notice the not congruent triangles. You could not place one triangle on top of the other to show that they're the exact same figure. In two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure. In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent, meaning that all the sides will have the exact same length and all the angles will have the exact same measure. Let's look at these congruent statements. When you write a congruent statement for two polygons, you always want to list corresponding vertices in the same order. You can write congruent statements in more than one way. Two possible congruent statements for the triangles would be triangle ABC is congruent to triangle FED. Notice in the figure that angle A and angle F are congruent, so they both come first. Angle B and angle E are congruent, so they both came second. Angle C and angle D are congruent, so they both come third. You can write this in any order so long as those corresponding pieces stay in the same position. Again, note, angle with one mark is congruent to angle with one mark. The markings on the triangles are extremely important. Corresponding angles, angle A congruent to angle F, angle B congruent to angle E, angle C congruent to angle D, and corresponding sides. Notice the order. If we want to say AB is congruent to a side, then we have to go from corresponding angle to corresponding angle. So angle with one mark to two marks needs to go one mark to two marks. So this would need to say FE, not EF, to stay in the same order. Angle BC, 2 marks to 3, would correspond with angle ED, 2 marks to 3. And angle AC, 1 angle marking to 3 angle markings, would correspond with angle FD, 1 angle marking to 3 angle markings. Or you can note, or as well as noting, that 1 tick mark would be congruent to 1 tick mark, and so on and so forth. So let's look at the triangles to the right and identify the corresponding angles, the corresponding sides, and then let's write a congruent statement. I'm going to do this in a little bit different order than you're seeing here. Corresponding angles would be angle K congruent to angle S, angle L congruent to angle R, and angle J congruent to angle T. Using the markings to help me write the corresponding angles. Corresponding sides would be JK, 3 markings to 1, congruent to TS, 3 markings to 1, and so on and so forth. If we want to write a congruent statement stating that the two triangles are congruent to each other, then I just need to make sure that I stay in the same order. So if I begin with triangle JKL, meaning I'm going from 3 markings to 1 marking to 2 markings, I just need to do the same thing in the second statement. So 3 markings to 1 marking to 2 markings would be TSR. Okay, so if we know two figures are congruent, that means we know all the sides are the same length And we know all the angles are the same measure. So if we want to find the value of x, we're going to go to the figure and determine where's x. X is right here, 2x minus 4, representing the side QR. So if we go to our statement, we're going to notice that QR corresponds with FG. This is going to allow us to write an equation that uses x in order to be able to solve for x. So now we know, according to our statement, that FG is congruent to QR. And we can replace FG and QR with their corresponding measurements in the diagram. FG is 12 and QR is 2x minus 4. And now I can simply solve for x by adding 4 to get 16 and dividing by 2 to get 8. Now let's solve for y. Y is represented by angle Q. The angle that corresponds with angle Q is angle F. So we can say angle F is congruent to angle Q. And then we can replace the measurements of F and Q and solve for y. Angle F is 68 degrees, and angle Q is 6y plus x. We already determined what x was, so we're just going to replace x with 8. Subtracting by 8 and dividing by 6 leaves me with the value of y being 10.
What's up, everyone? Welcome to this lesson where we're going to explore the different triangle congruence theorems. So let's start out by asking the question, what does congruence even mean? We like to think of it as this equal sign with the squiggly line over it. But let's just take a few moments to really conceptualize what congruence means, especially in terms of figures. So let's look at a running shoe. If I can somehow duplicate this running shoe and make an exact replica, I would say that these two shoes are congruent because they are exactly the same size and shape. Now, even if I change the color of one of the shoes or I rotate it around a certain number of degrees, it's still congruent to the original sneaker because it's the same size and shape. And we want to extend this kind of thinking now to comparing triangles to see whether or not they are congruent. If their corresponding sides and angles have the same measure, then we can say that the triangles are congruent. And this applies even when the figures don't have the same orientation, and visually it's not so easy to tell whether or not these triangles are congruent, and this is where our theorems are going to come into play. So the goal of this lesson is to help you to understand why the theorems that we use prove congruence and how to know which theorem to use in a particular situation. So here are the 5 triangle theorems with their abbreviations. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So now we're ready to go ahead and explore each theorem individually. Now the side, side, side triangle congruence theorem states that if in 2 triangles we have 3 pairs of corresponding sides that are congruent to each other, that means that they have the same length, then that's enough information to say that the triangles are congruent to each other. Which again just means that both triangles are exactly the same size and shape. So in this instance, we can use the side, side, side theorem to conclude that the triangles are congruent and that their corresponding sides and corresponding angles have the same measure. And remember that this relationship is still true even if the figures have different orientation. Our next theorem is side, angle, side. Now for this triangle congruence theorem, we start with a pair of corresponding congruent sides in two triangles. We also have a pair of corresponding angles that are congruent and another set of corresponding sides that are congruent. Now see that the letter A is in between the two S's in the name of the theorem? This corresponds with that congruent angle being in between the two congruent sides. Now when this is the case, we have enough information to say that the two triangles are congruent by using the side angle side theorem. Our next congruence theorem is the angle side angle theorem. When we have two triangles with a pair of corresponding congruent angles, a pair of corresponding congruent sides, and another pair of corresponding congruent angles, we have enough information to prove congruence using angle side angle. Now it's important to notice that the congruent side is in between the two congruent angles. And now we can visualize that when this is the case, we have enough information to prove that the two triangles are congruent by angle side angle, which means that all of their corresponding sides and corresponding angles have the same measure. Now our next theorem is very similar to the one that we just looked at, which was angle side angle. This one is called angle angle side. Now when in two triangles, we have a pair of corresponding congruent angles, along with a second pair of corresponding congruent angles, as well as a pair of corresponding congruent sides. Now we don't want to confuse the last theorem, angle side angle, and this theorem of angle angle side, because both of them involve two congruent angles and one congruent side. The difference is that angle angle side, the congruent angles are consecutive, that is that they are one after the other, and then the congruent side is next to them instead of in between them. Now even though the order is different, we still have enough information here to prove that these two triangles are congruent, which means again that their corresponding sides and corresponding angles have the same measure. Now our final congruence theorem is kind of a special case. It's called hypotenuse leg, and it applies to right triangles only. So let's start out with the key feature of any right triangle, and that is a right angle. Now we know that the hypotenuse of a right triangle is its longest side and is always opposite the right angle. So this congruence theorem says that if the hypotenuse in both right triangles are congruent, and if a leg, which is one of the other sides, are congruent, that is, they have a pair of corresponding congruent sides, then that is enough to say that the two triangles are congruent. Again, which means that the triangle's corresponding sides and corresponding angles have the same measure. So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent, okay, so we have 2 sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side side, however, the base of each triangle clearly are not the same, and these triangles clearly are not congruent. Thank you so much, guys, for checking.
Okay, so take a moment, pause the video, and get the side, side, side postulate down in your notes, which says that if you are given 2 triangles and you are told that these corresponding sides are equal, that means everything about the triangle has to be equal. And let's look at an example. It says, decide whether the congruence statement is true, and then explain your reasoning. First congruence statement says that triangle DFG is congruent to angle HJK. So the first thing I note is that DG is congruent to HK. And the second thing I note is that FD is congruent to JH. Third thing I note is that FG is congruent to JK. Which tells me that yes, triangle GDF is congruent to triangle KHJ because I know that all three sides are congruent. Number 2, triangle ACB is congruent to triangle CAD. So let's look. I see that AD is congruent to BC because they have the same measurement of 7. But then I notice that AB is not congruent to what should be CD. This symbol, the congruence symbol with a mark through it, means not congruent. I can really stop there, but let's keep going. I know that AC is congruent to itself. That would be my third side if I were to pull these two triangles apart. This is called the reflexive property. When we say one thing is congruent to itself, they share that thing. But it turns out that no, these two are not congruent to each other because we cannot apply that all three sides are congruent. And even if one piece is not congruent, we say the whole figure is not the same. Number 3, triangle QPT is congruent to triangle RST. Okay, QT is congruent to RT. QP is congruent to RS. And PT is congruent to ST. So yes, all three sides are congruent. Triangle TQP is congruent to TRS. Or QPT and RST. I maybe should have used this statement. Okay, take a moment and write down the postulate for side angle side. Once you have it, let's look at an example that shows that if you have a side and the included angle congruent to a side and the included angle between the two sides corresponding with each other in two triangles, that these two triangles are congruent. This one's a little more challenging. In the diagram, QS, which is this line segment, let me get a marker here, QS and RP pass through the center of the circle M. What can you conclude about triangles MRS and MPQ? Well, the first thing I note here is that RM, SM, QM, and PM are all a radius of this circle, meaning they are all congruent to each other. This is going to be very helpful because now I can say that RM is congruent to QM when I begin comparing these two triangles. I will also note here that these angles have to be congruent to each other because they're vertical angles. So in this triangle, or these sets of triangles, things aren't marked. I have to determine whether the pieces are equal or not, and then make a determination about whether they're congruent triangles. So I have a side and I have an angle, and my hope is that the next side will also be congruent. Well, I already said they were because they're a radius. SM is congruent to PM. And so now I have side, angle, side, and I can say that triangle RMS is congruent to triangle QMP. Take a moment and write down the theorem for hypotenuse leg. Remember that in a right triangle, the side across from the right angle is called the hypotenuse, and it's always the longest side of a right triangle. The other two sides are just referred to as legs, and they won't always be the same measurement, but they could be. In hypotenuse leg, if you have two right triangles and the hypotenuse are the same length, and you have one set of legs that are the same length, you can say every part of the triangles are congruent to each other. Let's look at an example. It says use the diagram at the right, and then use the information in the diagram to prove the triangle ACB is congruent to triangle DBC. You might find it helpful in this one to separate the triangles and set them in the same orientation. So if I'm looking at, let's say, this triangle right here, angle B is the right angle. And then if I flip it upside down, AB becomes the bottom. So that would make this angle A, meaning that this up here would be C. Here's my right angle. This one I don't have to change the orientation. Here's my right angle. And my right angle is C. And then my base is D. And up at the top we have B. And if I carry my markings over, I'm told that the hypotenuse, which is AC, is congruent to the hypotenuse, which is BD. It's also important to note here that BC, right here, is a side of both triangles. So it's going to have to be congruent to itself. Okay, now let's make some geometry statements. First thing, triangle ABC and DCB are right triangles. That's a given, but it's important because we're wanting to prove hypotenuse leg, which only works for right triangles. Side AC is congruent to side BD. That's the hypotenuse piece, and that was given to us. Now we need a leg. Well, we already said BC is a side that both triangles share. So obviously it has to be congruent to itself. Remember, I referred to that as a reflexive property. Telling us that triangle ABC is congruent to triangle DCB by hypotenuse leg. Angle side angle and angle angle side. Take a moment and write down these postulates in your notebook. It becomes difficult to tell the difference between these two because in both pictures, you're given two angles and a side. So the thing you have to determine is, in the picture, am I given two angles and a side between them, which would be angle side angle, or two angles and a side not between them, which would be angle, angle, side. So pay attention to what's given and the placement of where that side is, whether it's between the two angles, angle, side, angle, or not between the two angles, angle, angle, side. Let's look at an example. Determine in the diagrams which of the following are proven with angle, angle, side or angle, side, angle. Let's look at the first picture. We see two angle markings and a side, two angle markings and a side. So we look at the angle markings and we decide, okay, is the side given between them? And if it's not, then it has to be proven with angle, angle, side. And you can see that angle, angle, side in that order. Let's look at the next one. We need a little extra information in this next one. We're told that AD is parallel to CE. And we're told that DB is congruent to CB. And we can gather that DBA is congruent to EBC because they're vertical angles. And it seems like we're not given enough information, but we need to use the fact that these are parallel lines. And if these are parallel lines, then what's happening here is, do you remember from the previous lesson that if I can make a Z where part of the Z, like these parts of the Z, are the parallel parts, that the inside of the Z are alternate interior angles. So I'm actually given alternate interior angles when the sides are parallel. Okay, so now I have two angles and two angles and a side. And so I need to determine, is the side given between the two angles? And if it's not, which it's not, then my answer should be angle, angle, side. So when I worked this problem the first time, I found that it was angle, side, angle. So sometimes you can prove using more than one thing. So let me show you how this could be angle, side, angle instead of angle, angle, side. So instead of making my Z this way, I could make my Z this way. And this is also perfectly legitimate. Just goes to show you lots of ways to do the same thing. Here's the inside of my Z this time, so that's congruent. So now you can see that you've got two angles and a side between them, two angles and a side between them. So that's your angle, side, angle. So this one, depending on which one you said was congruent, you could say angle, angle, side, or angle, side, angle. Okay, next one. We're given two angles, congruent to two angles. And we've got PR congruent to itself. Remember, if they share a side, you can go ahead and mark that because that's obviously going to be congruent. So now I've got two angles and a side between, two angles and a side between. And so this one is going to be angle, side, angle. One more. I'm noticing vertical angles that have not been marked, so I'm going to go ahead and mark those vertical angles because right now I feel like I don't have enough information. I need three pieces of information, right? I need to figure out where's the angles and where's the sides that are not marked, but I know to be congruent, like vertical angles. Okay, so here's what I see. I see angle, angle. I see angle, angle, but I don't know about the side between them. So this one is angle, angle, side, angle, angle, side, because it doesn't tell me anything about the side between them. So this one has to be angle, angle, side. All right, guys, almost to the end of this lesson. If you feel like you need to have the theorems all summarized in one place, go ahead and hit pause and make a note of this in your notebook where you've got all the triangle congruence postulates and theorems together on one place. Now let's look at an example of trying to tell the difference between all of these. Well, I've already got it pulled up. I thought I had it on animation mode, but apparently I don't. That's okay. We'll do it this way. So it says, what postulate or theorem would you use to prove the triangles are congruent? So in this one right here, again, go ahead and mark any common sides that have not been marked. We're given side congruent to side congruent to side congruent to itself. That would be side, side, side. Next one. Go ahead and mark vertical angles that are not marked, giving us side congruent to side, angle congruent to angle, side congruent to side, side, angle, side. Hypotenuse leg, two right triangles, mark the side they share. So you've got hypotenuse congruent to hypotenuse, leg congruent to itself on a right triangle, hypotenuse leg. Mark the side that they have in common. Notice here that you've got parallel sides, so you're looking for the Z right here. And you know that inside of that Z has to be congruent because of alternate interior angles. So that's angle, angle, side. Angle, angle, side. Next one, you've got side congruent to side. You've got angle congruent to angle. Now, if I'm looking at this triangle right here, this angle is congruent to this angle, okay? So I'm noticing that I've got two angles and a side, and the side is not between the two angles. The side marked is not between the two angles, therefore it has to be angle, angle, side. Angle, angle, side. One more. I see angle congruent to angle. Angle congruent to angle. Side congruent to side. So I've got two angles and a side. So I just want to decide, is the side between them? Here's my two angles. The side is not between them. So it has to be angle, angle, side again. Okay, so now it's time for you to go practice on your own. When you feel confident, go ahead and do the quizzes, take the quiz, and then move on. Good luck, you guys.